So today we'll look at aspects of increasing password security, and we'll look at some other authentication methods. Note that we'll continue to discuss authentication method till almost till the very last of the course. Okay, so these are the simple authentication methods. Afterwards, we'll start looking at encryption algorithms and so on. Then we'll see how we can apply some of those concepts in authentication. Okay, all right. Okay. So basically, okay, so far we have completed following things. We looked at security basics. We looked at the basic concept of threat, vulnerability, risk, difficulty of developing secure system. Internet is not designed for security, and complexity of software and hardware. So these concepts we studied in the beginning, the first class. Then we look at the basic security principles which you can apply when you as a software designer or system designer you work in future, or when you develop software. We can look at some of these aspects, right? First thing is that you should know your threat model, because you have to secure against something. What is to be secured? An asset is to be secured. Okay, then you have to think what kind of threats are possible, right? And what are more common threats, and you cannot secure for all possible threats, but then you need to decide what all threats you need to secure the assets against. Okay, and then we have looked at the human beings are they don't like complexity, right? So when we design a system which is a secure system, it has to be simple in nature, in the sense that if you present to a user multiple logins and so on and so forth, right? So, or multiple factor identification, so they don't like it. Okay, security doesn't come free, so you'll have to decide what part of the system to secure, because you have to spend money in order to secure it. Detect if you can't prevent is something that, in case of theft, or in case of you know data breach. Okay, we need to first detect, right? Defense in depth, least privileges, separation responsibility, complete mediation. Complete mediation means that through one common point all requests have to go through, right? Like firewall, and everything has to pass through that, or for example airport gates and so on. So don't rely on security through obscurity. When we design encryption algorithm, the algorithm for encryption has to be known. Keys can be random. Keys can be different, but when you design a lock for a house, the design of lock has to be known to everyone, including thieves. Okay. Fail-safe defaults, design in security from start. So all these concepts we studied, and then we further studied about trusting trust. Basically, it means that you cannot trust any software that's written by anybody, because bug can be there right in the compiler, or the developer who designed it, or even after that. Okay. Then we looked at CIA concept: confidentiality, integrity, and availability. Then we looked at authenticity, authorization, non-repudiation, access control, privacy, and we looked at the concept that why human beings are the weakest links, because they can be easily fooled. Then we started looking at access control and authentication methods, and one of the authentication method is password. So that's what we are studying now. So this is the flow so far. Okay, all right. So last lecture we have seen that passwords, when you set your password, it's not stored in the system in plain text. About 30 years back, passwords were stored in a Unix system or server in a plain text. Okay, so anybody could hack the machine, then passwords were available, or even system operator, because system operator will know password file, and then system operator has access to it, means that all the accounts, and can also uh, can also pass on that password file to thieves if uh, if the person thinks so. Okay, so nowadays the operators have no clue what your password is. Okay, so if you ask system operator or your IT guy to change that you want to change your password, you've forgotten it, then he or she may send you a link through which you will have to set the password. So in all systems today, okay, operators are not supposed to know your password, and if you get any password, then there's something wrong. In fact, in your organization, I found that still passwords are being set. Okay, all right. Uh, so what we do is that when we have plain password, because you set always in text, right? Plain text, like for example, I will set as Ravi. For example, one of the very poor password is 123 at the rate. Okay, so it is hashed. Hashing is one way function. It will convert this into some string, say 15 a small b, x at the rate exclamation, something of some length, and this length is usually quite high, say 128 to 256 or sometimes 512. So every time you put this string, you will get the same output, right? Okay, we'll look at this cryptographic hash function later. And if you change a minor change, instead of 1 you change, for example, it's a RAVI 123, so make it small, RAVI 123 at the rate, then this string will be very different from previously generated string, right? So there's a characteristic of hash function. And once this hash passwords are available here, when you have set it, and you set, when you want to log in, you give your password in plain text, and then what will happen, this is a setting process, and then later on when you present your password, its hash is computed in real time immediately, and then this hash that is generated from presented password is compared with the original hash password when you have done the setting, right? And if both match, then you are allowed to get into. Now password attack method is that this H of all users, P is for one person, but it's for all the users is available. Okay, now this file is called password file, is available, okay, through a data breach. So this first thing is that let this file be available, or even darknet you can find these files. Okay, you steal this HP, okay, and then offline you crack this HP and get P. How do you crack it? That last class we discussed that hashing function, this available. So now you generate random list of possible password. Okay, first use dictionary words, and then you can generate randomly all combinations of 7 characters, 8 characters, 9 characters, and so on and so forth. And then this file, output of that file is available for, first you generate all these combinations and then hash it, and then this file, that is hashed file of all possible combination, is called static file. This static in nature is available. Now you have this hacked file available, and just compare that, and you will be able to crack many of these. Okay, so we have seen dictionary attacks, we have seen brute force attacks, and hybrid attack, which is combination of these two. Okay, any question till this point? No? All right. Okay, and then we have seen that by increasing the length of password and use of, and also using different types of characters, or increasing the character set also, okay, you can exponentially increase the key spaces or number of possible combinations, right? So if you set, for example, a password of 12 characters, that includes capital letters or or small case letters plus special characters plus digits, okay, then it's very, very difficult for any uh, cyber criminal to crack it. Okay, even length of 8 that most of the companies insist for your password with special character is quite hard to crack. But better is that you keep it in longer passwords than this. Okay, and what you can do in fact is that instead of a 8 character word, you can use a phrase. So for example, you can use a you say that I write down first, I went to shop, a shop, or beach. Okay, now in this you change something, right? Now you remember this, I went to a beach is easy to remember, is so you change I to for example 1, which looks very similar to this. Went you change it to W, then make some changes, 2 instead of TO you change it to, and so on. Then you create a password like this, which will be extremely difficult because this is usually 20 more than 20 characters long. Okay, all right, I'm telling you a trick. Now the question is that how do you make life difficult for cyber criminals who can use tools or even GPUs and very fast computers, even cloud, for cracking your password? You'll have to make their life difficult, right? Because there's a continuous race between cyber criminals and the people who are protecting the security or providing the security, right? Okay, first thing is that this hashing algorithm is known. Okay, now when you present your password, when you are setting up your when you're setting up your password, then this hashing algorithm will take your password, say Ravi123, okay, and convert into a string. So it will take some time t. Now if you make this process slow, how can you make this process slow? You don't have control over CPU, what somebody will use. All you can do is algorithmically you can make it more complex. Now instead of 1 millisecond, it will take 100 millisecond while setting it up. Okay, also while checking, because it has to do similar function, it will take 100 millisecond, for example. Now for a user like you and me, whether I am taking 1 millisecond or 100 millisecond will make no difference. Okay, so what I am going to do is that make this process slow for but cyber criminal has to do it for all possible dictionary words and randomly generated words and so on. For him, even generation of static file will be very hard because it's going to take huge amount of time. It will take months. Okay, so there's a first trick that we use. This is one of the tricks that we use, right? This is the one, reducing the speed to cracking using slow hashing algorithms. Okay, one such hacking algorithm is a bcrypt, okay, which is slow, takes a lot of steps. Okay, so it will consume lot of memory and CPU cycle that you can design easily. I mean, you can design algorithm which is not efficient. Okay, and second is that increase the key space. How can you increase the key space? By larger character set. Now character set for you is more or less fixed because there's something that's available on your when you keypad. Okay, you can't just use more than that, right? Of course, there is a you can define more than that, but something that you can type in, you'll use only that. So it's restricted to whatever we do, right? I mean, all a to z, then small case a to z, then 1 to 9, and then special character. Okay, all right. So there's increasing the key space. There's a first way that this character set should have combination of this, and second is that use of salt. Okay, we'll study now what is salt. Okay, so now these two methods we have. First, as we have seen, is that increase the complexity of the, so slow down the, basically slow down the hashing algorithm, and we can, what we can do is we can do this hashing multiple times, and that itself is slow. Okay, all right, so this is method of slowing down. And second is, as we said, is that when you present a password, system will add a salt to this, and then when you set it up, for example, when you set your password, you say my password is Ravi123 at the rate. Okay, it will add to this some salt, which is a, say, 128 random characters. Say it could be ZW1 exclamation mark or whatever. This is random, right? And it will hash this and store. Okay, so when you present your password, when you log in, you will present this hash is saved, and will apply this hash and do the comparison and so on, right? So the question you may ask is, how does it help? We'll look at that, right? Before that, let's look briefly about this concept. So when password is created, system provides additional randomness to password. Okay, so I may, we don't want complexity, right? So we'll set very simple password, say Ravi, maybe 123, or maybe 1 2 3 4 5 6, if system allows that. Okay, now how can the system increase randomness? So for example, in this, if my password becomes Ravi123 ZAW exclamation mark 9, something like that. These are all random characters of, say, 128, the 128 characters, right? And this becomes my password in the system. Now this uh, salt is available in the system when I present, sorry, this salt, when I present my password Ravi123 at the rate, or what do you, then it will add to this password when I present this random salt that's created only for me, and hash of that, do hash of that, and compare with something that's available right in the beginning. Okay, any question?
Adding is it only the end or is it anywhere? It can be anywhere.
So that of course algorithm based, you can do it in the beginning or end, doesn't make any difference. Okay, any other question? There must be a lot of question. How does it really help? Because note that when data breaches happen and password file is leaked, this salt is also available, because salt is always in plain text. So what in a leak, what all is available? When leak happens, my user ID, which is in plain text, then hash password plus salt is available. Okay, plus salt is available, which is in plain text. So now these things are available about me. So how does it help us? How does it pose difficulty? Because now this is known. So so now cyber criminal can always use common names like mine, say Ravi123 will try, and then put salt. Salt is available from breach. Okay, and apply hash function to this, and whatever is output, and compare with hashed entries in leaked file. Okay, any idea how does it help? All right. So one answer is right here, although it's not the main answer. User with the same password have different entries in the password file. So, for example, you have set your password as 1 2 3 4 5 6 7 8. Okay, and if there's no salt h of this, will it will be a string, right? Now your friend has also said this. It will be same string. So now one crack is there, then it can find out multiple user has this password. That's of course very intuitive. Okay. Other thing is that you are using same password in different places. You have account in bank and your intranet account and other places, right? And using same password, then this salt each system will apply. Wherever you are putting your system, where you are creating a login credential, so the salt will be different because they randomly generated the time of creation of account. So your one password is leaked, so it will not be useful for cyber criminals in other places, right? So now the method is as follows. Then we look at the how does it help. When you're setting password, say Sanjay123, you add this salt S41 small t, then your total password becomes you put the salt before the actual password, so it becomes S41T Sanjay123. You apply hashing function, and okay, then in the password file you save salted hash, whatever you have done. This is salted password, hash of this is salted hash, and then you have to keep salt in plain text, because when you are doing checking, then you'll have to use this salt. And what do you do then? When you want to log in, you input password. Your input password is Sanjay123. Okay, and what system will do? System will use the stored salt, which is S141T, and then the password becomes this. It will apply hashing function, and what you get is salted hash. If it both match, stored one and this one, then you're allowed, or login process passes, right? Or password is accepted. Okay, this is a process. Now, how does it help in slowing down things? The whole idea is slow down. Now, hash function is known, so you cannot say that hash function. So, cyber criminals have access to hash, right? Okay, so now what cyber criminals were doing earlier, they have created a table, a static table, okay, and with commonly used passwords. Okay, or rainbow table they created, like 1 2 3 4 5 6 or whatever, or Ravi 1 2 3, or 0 1 2 3 4 5, or some common names, right? Or password 1 @ something like that. Okay, and then they have applied hash into each one of these and got this static file. Now, what will happen now? So this is very simple to crack. Now what you are doing is, to each of these you are adding 128 bit of randomly generated string. Okay, so now look at, for each common word like 1 2 3 4 5 6, this could be anything which is possible. So let's assume 128 is the length of this. So minimum, and of course these are characters, so we cannot say 128 or something like this, because each character will also have some certain number of bits. So let's assume that, okay, let's assume that this 1024. Okay, So now the difficult, instead of making a one hash, it has to look at all possible combination of this, and then its table size will increase by this much. Okay, and it has to do for all. Now you increase this from 128 characters to 256 characters and so on, then the search space for the criminal will really be huge. Okay, so if you take 12 bits of random sort, now you're talking about not character but bits. Okay, so it will hash into 2 raised power 12 different hash values, and attacker must try all dictionary word with each salt value. It means that, for example, the original password is 123 up to 8. Now it has to do attach this with 2 raised power 12 different values of salts, and do the hash of this, and then store in the table. So it means that now it's very hard for cyber criminal to handle this, right? So there are some statistics are there for certain. If your CPU speed is something, and then you are using GPU, and then uh, how many hashes it can do, and then how much time it will take to crack it. You can find all these statistics anywhere in the system, right? And we will find that bcrypt algorithm is very slow, and uh, it poses difficulty because of its slowness. All right, any question? Okay, so what we have discussed so far? Okay, so I'm repeating this because I think that it's important. Oh, just a minute.
Sir, I have a question.
Yeah.
Sir, like the hashing is a function, right? Like which maps from one string to another string with a complex. It's
Yes.
a complex function.
Yes.
If the algorithm or the function is available for a hacker, why can't he train a neural network or the AI and deep learning models like which are available right now, which decreases this probable, I mean, the risk, increases this risk. Then.
So this is very simple problem to crack. Okay, all you have to do is that you can apply AI also. You can find out, you can what AI can do here.
I mean, like if we train the model to find the inverse function from the hashed password to normal
No, no,
password using this distance
that's a failure of hash.
failure of
Okay, failure of hash. It means that you cannot. One thing we have studied in hash is there's a one-way function, and we'll look at why. If you are able to find out inverse of hash, then you have done a great job. You will get possibly Nobel Prize. Okay, and we'll see how why it is so complex little later. Okay, so whatever method you apply, you cannot do inverse hash. We have said it's a one-way function, right? One-wayness. Another property we have studied, we'll study them later also, because right now we are just presenting the concept. Second is the collision resistance. So AI you can do to do proper guessing of the password, not for hash function. Hash function anyway algorithm is known to you.
Yeah, I'm saying for the guessing itself. We can guess
Yeah,
instead of
so
having the
we can
random.
you can yeah. So your question is not about hash function, because inverse is not possible. Given you a password, hash password, you can apply inverse function, okay, and get the password in one stroke. All you have to do, the exhaustive search. Okay, now second thing you can ask is that now you are generating a rainbow table, right?
Yes.
or basically all common appearing passwords, right? Like you and me set, like your what your grandfather will set, will take up your name or your sister's name as a password and so on. So all these dictionary words and commonly used words you can create. So how do we you can apply AI to reduce this rainbow table size? Possibly, I don't know, or make reduce the search space. What
Okay.
else it can do?
Yeah, that's what I'm saying, sir. Like reducing this
Yeah,
space of
you
this.
can do it. You can think about it. Think
Oh.
about it. Then how to reduce the size of search space? That's it.
In
That's
that
what.
case, like how can we protect our system? Like then is there any possibility or that such cases
Hmm. That is a race continuously. People are using AI, deep learning, etc. for a lot of. So if cyber criminals start using this, you think of how to protect from them, because search space, obviously search space cannot be reduced to very small. And now you have cloud available. You can use millions of bots to crack an algorithm very fast. Okay, so this
yes,
is a continuous race, and then you have to make things harder for cyber criminals. Maybe you should use much slower hashing function. Maybe you should use much longer salt. Maybe and password may fail. Let's assume the intelligent schemes come, then password may fail, but then you have to use password is just one of the multiple steps of access control. Okay, so what you can do is that first present your password. Okay, if you are successful, it will say now you will send OTP, one time password, and if that is true, then your face biometrics, face recognition, or could be anything, I don't know. I mean, now Google does it differently nowadays, right? I mean, sorry, my login, when I do login into my, some stockbroking sites, then it will present my a code into some particular application on a different device. Okay, there can be multiple steps in authentication. All right, and this continuous race. I mean, if the password seems to be very simple. And the question I am asking is that how many of you have set multi-level authentication or two-step authentication even in your most important account, which is your Gmail account? Most of us is Gmail nowadays instead of some other. All work very similarly, and this is a primary account for most of us. Okay, and then how many of you have set multiple level of authentication in that? Most of us do it only with password, right? Why? Because you don't want to, it's irritating to have multiple steps, right? Because you may receive OTP or you receive phone call or whatever, second step, and then you don't want to spend time. You think it's irritating. I mean, so we want simplicity. That's the reason multi-step authentication is necessary nowadays. The passwords can easily be cracked. Okay, so for most of us, our passwords, if we have used one of these social media sites like Facebook or Twitter, etc., etc., then our password of that is already available in leaked passwords are available, hash salted passwords are available. From that, cyber criminals by now would have found out actual passwords. Is certain. Okay, so what we are doing by salting is increasing their time to crack it. That's it. A small cyber criminal will not be able to crack, but anyone with access to millions of bots can crack it, or cloud can crack it easily. Okay, all right. Any question? More question? All right. So what we have studied now is a password. Actually, if you have time, then we can actually have a demo wherein we'll try to get one password file and then use hash function. And you can do this experiment by yourself and ask your friend to present a password and then crack it. Okay, using this tool, and these tools are publicly available. Okay. Now, something that we also say, one level of authentication is authentication with something you have. This already we have used. For example, password is something you have, or you can have some physical thing like you can have tokens or smart card or RFID. In the organizations, most of the organizations you have a smart card, and then you swipe it and then it works. Okay, most of the credit cards and debit cards are now uh, use a similar method. It's something you have. You want to make a payment, and then you, instead of swiping it fully and typing in your name, you just through RFID it can read that what is actually you, and whoever presents it can do the transaction up to certain amount. After that you have to input the pin. Okay, so we use this something that we have, right? Now it can also be little more complex, that it can send the challenge. So there's a user and the system, and there has to be some device here, right? So when user is presenting the credentials, okay, say want to make a payment for something, it will go to system with user ID. Okay, and system will challenge the user to present the pin, and user will type in the pin, it will go to the system, central system, and then it will allow this payment, right? So it's called challenge response. Now challenge response, what we presented here, when you input your pin in your credit or debit card, is more simple, but it can be made very, very complex, right? I mean, where multiple steps of authentication can be there, and uh, we'll look at some of these if time permits. Okay, so this something that we have. Next is something you are. You don't need to carry anything. Okay, you just need to be there, right? I mean, you don't you reach office, and then the situation shouldn't be that you have forgotten the ID card that has built in, what do you call that, RFID or something, which you present to system and will recognize that. Okay, it's not even challenge response kind, right? You just, I mean, like your ID card works entering a lab, right? It does not ask you to enter pin. That's second level of complexity. First is just simply swipe it, right? So if you forget that, then you can't enter the office, right? So instead of that, most simple is that you just walk into the office or somewhere and then present yourself. What can they check about you? If it's your home, then your parents know that's you. Okay, if it's a system, then system will look at what? We will ask you to present your fingerprints, or we'll look at your face, and or within face, in your eyes, to look at iris and do some calculation and say, okay, you are you, and then let you in. Okay, these are called biometrics. And in a passport, for example, nowadays, or your visa, US visa, you will require biometrics nowadays, because there's an additional level of authentication. Earlier, when I made my visa, US visa, about 30 years back, then it was just photo and signature, nothing more than that, which can be faked, right? But biometrics chances of faking is very, very small, maybe 1 in 1 million. Okay, so biometrics, it could be by various methods. It could be fingerprint, okay, or it could be voice, it could be retina. Okay, it's a keystroke dynamics. I don't know what it is. Maybe I will look at it. Okay. Okay. So what will happen? What is it system going to do with my eyes? Is it going to store that photo of my eyes? Anybody? What's happening here? So when you do your face recognition on your mobile, is it going to take my first when you create a when you set this up? Okay. Is it going to? Of course, you'll have to scan your face, right? In the through the camera. Is it going to take my photo? It will store my photo, and every time I present myself for login, it will check whatever is seeing me in camera with that stored photo. Is that the process?
It will compute something and check if the value match. Like, is it kind of?
Yes. So it's going to compute something very good. So what is it going to? So there has got to be some algorithm. Okay. And there has to be some uniqueness here that's not in other people. Okay. Something that I have will be different from what you have, right? Only then authentication can be done. Okay. All right. So there has to be some uniqueness, and iris is one which is very unique. Fingerprints have always been unique. Like fingerprinting has been used for ages, like 200, 300 years. I mean, old stamp papers, you will see, you write a document and then you put a thumb impression. Okay, all right. So these are all unique, right? But now, because of electronics and digital methods, we can do this whole process very fast. All right. So earlier, thumb impression, somebody's thumb impression is to be checked with your thumb impression, it will take minutes, right? And sometimes hours. So advantage of biometric authentication is nothing to remember. Okay, it's a passive. Oh, you don't have to remember a password, for example, in the first case. Okay, it's a passive. You don't have to type anything. Okay. Uh, you can't share it. You can't share your face recognition with somebody else. Okay. Uh, and is a fairly unique. All right. So basically, there are two steps: identification and authentication. How do you identify something? For example, in a fingerprint at the crime scene can be used for identification. Okay. Now we have studied these concepts earlier, right? When you present it, you know, when you present a fingerprint, then you are identified as a person X. So the question you can always ask that you present your fingerprint, can it be of some other person? Probability, the system says yes, but this probability is very low. The okay, failure rate could be 1 in 1 million or even higher. Authentication is, of course, verifying the claimed identity. So when you present it at the entry of your office, then it will identify you and let you in. Okay, so fingerprint scanners are there in at the gate of the building, so that will allow you to get inside. All right. So okay, so face recognition is very common nowadays in your laptops, or your mobile. I use nowadays on my iPhone face recognition for getting into iPhone. Okay, because it's simple, as simple, or if sometimes it fails also, if I don't do it from proper angle, then I have to input the pin. Okay. So error rates could be very high in face recognition if you want to use simple algorithm. It also depends on a lot of other factors, like from which angle you are taking the photo, variation in lighting, what is the expression, and so on. But it's simple and it works. Then fingerprinting, use the fingerprint. It's very powerful, very unique. Okay, probability of false match is 1 in 10 billion, not 1 million, but 10 billion, and so on, right? All right. Again, the question is that how do you, when you present it, how system can calculate the values, or it based on this it will do some calculation and come out with a range of values, and what is that, how fast it can be done. Okay, that's the question. And nowadays we have algorithm and systems which can do it very, very fast. So it is very much in use. Then of course we have iris scanning. Irises are very random, right? It changes. It's a its randomness changes from, or basically it's a very different for two individuals. Okay, but it remains stable throughout the life of a person. So it's unlike signature, right? And banks earlier, even now you present a check, you sign, and so what happens is that when I signed when I was 20 years old versus 40 versus 60 versus 80, signature changes. So every time, every 10 or every decade or 2 decades, person has to go to the bank and say, this is my new signature. Otherwise, they will reject your check. But iris will remain stable. So it is 250 byte iris code based on concentric rings between pupil and outside of iris. So there must be some algorithm, some way of calculating this code, 256 byte code. And the error rate is here 1 in 1 million. All right, so we have just very briefly looked at these methods. If you're interested, please go through details of these. You can find it in many books. Okay, but there are many problems with biometrics. As we have seen, it's ease and we can always use this for authentication. Error rates are generally low with fingerprinting. Face recognition error rates are, failure rates are higher. Okay, they're basically false negatives are higher. Okay, uh, the problem is that it's a private but it's secret. Sorry, private but not secret. I'm so sorry. Okay, so I mean your face is not secret, right? Is it secret? Okay, so you can so that's one disadvantage is it essentially it can be forged easily. There are some very smart ways of forging. Okay, even a random looking biometric may not be sufficiently unique for authentication. Like for example, in case of face recognition, potentially forgeable, which comes from these two. Failure to enroll and can be cloned. Okay. So there are terms associated with this: fraud rate versus insult rate. Fraud rate is that somebody is able to present as you. Okay. So fraud is system accepts forgery or false accept. Insult is that when you're presenting yourself and say no, it is not you. System rejects a valid user. So increasing acceptance threshold increases fraud rate and decreases insult rate. Okay. Fraud rate in for UK banks statistics collected was 1%, and insult rate was much smaller, 0.01%. Now, how fraud can happen? You can find hundreds of examples in system, right? In internet. Okay, can you do? If fingerprints are to be used as a biometric, or thumb impression is used as a biometric, can surgically you can change it? There's example here where a Chinese woman has done that and able to get entry into Japan. Okay. Can somebody steal the finger itself, right? Oh, they can cut the finger of the owner of asset and present it, right? So Malaysian thieves have done this. They could steal finger. Okay. Or can it be cloned? Can fingers be cloned? Your finger prints are maybe available, right? At many places. Okay, in wherever whatever we touch, most of the places our fingerprints are available. Can from that prints finger can be cloned? There have been attempts about it, right? Okay. And of course go through this cartoon. Okay, any question?